So quickly, I want to give you some basic questions from campus questions, and we're going to look into them one after the other. Now the first question is, how many unpaired electrons are there in 1s2, 2s2, 2p4. Let's start with that one first. How many unpaired electrons are there in 1s2, 2s2, 2p4? Now listen to me. See how I'm going to answer this question. Now the idea is questions like these are very common in the JAM past questions. And that's why I am taking my time to explaining something like this. Actually, if you need more clarity on questions like this, kindly refer back to my YouTube. Understand? Check my channel. You will see a video I made on electronic configuration and how to finding the number of unpaired electrons. But then, listen. Now, how many unpaired electrons are there in 1s2, 2s2, 2p4? First of all, the idea is how on earth can I get or write an electronic configuration for elements? That's not what you need here for this question. So in the course of writing electronic configuration for elements, kindly consult my YouTube channels on videos like this. I have made a video on how to writing electronic. So where I implemented Abel's principle, Pauli's exclusion, and Ohm's. Now the idea is, what you need here now is, how can you estimate the number of unpaired? And now, the idea of number of unpaired can be gotten from the concept of ohms. Now, first of all, there are so many ways I can actually attempt questions like this. The idea is, for a degenerate orbital, don't forget that don't forget I told you that there are four basic orbitals rather, the s, p, d, and f. And the s orbital can take a maximum of 2, p orbital can take a maximum of 6, d can take a maximum of 10, f can take a maximum of 14. You understand? Now from this, the s orbital has one degenerate. I said that. The p orbital has 3 degenerates. The d orbital has 5 degenerates. The f orbital has 7 degenerates. The question is, how do we get to know the number of degenerates each orbital has? Simple. Now the idea is the maximum number of electrons each orbital can take. All you have to do to get in their number of degenerates, divide the maximum number of electrons each orbital can take by 2. For example, this s orbital can take a maximum of 2. 2 divided by 2 is 1. And that's why the s orbital has 1 degenerate. The p orbital 6. Maximum number of electrons is 6. Divided by 2 you get 3. 3 degenerate. The d orbital maximum of 10 number of electrons divided by 2 s2, 2s2, 2p6, 3s1. So how do we estimate the number of unpaired? You notice that when I was teaching you the first example, I didn't come up with a simple concept. Now there's a simple way to answering this question other than doing that long form. Now the simple way is coming from here. Take note of everything that has been given to you. I have 1s2, 2s2, 2p6, 3s1. Now the idea is, don't forget I told you, I said the s orbital can take a maximum of 2. The s2, p can take a maximum of 6, d can take a maximum of 10, f can take a maximum of 14. Now don't forget, JAM questions are always time. You need to be time conscious. And that is why solving a problem like this, you don't need to go, you have to, the tricks is what you need. Now there's a simple trick to getting the answer. I'm going to teach you 2 tricks. Now pick which one works for you. Now the idea is, I will look for which orbital is not completely filled. When you look at this one, the maximum number is 2. Automatically, this particular one s orbital is filled. Move down to the next one. This is 2s. It's an s orbital. So the maximum number as well is 2. Whether 2s, 3s, as long as it's an s orbital, the maximum number of electrons it can accommodate or take is 2. So definitely this is completely filled as well. Move down to the next one, completely filled, because the p orbital can take a maximum of 6. Then move down to this, you notice the only orbital that is not filled is this 3s in question. And so then I will go to the 3s orbital. Don't forget. So the s orbital has one degenerate. I've told you why I'm going to this. Actually, you can start developing for all of this, but you don't need all of that. Since the exam is time, you need to be time conscious. The exam is timed, and so you have to be time conscious. Now, since this 3s is the only orbital that is not completely filled, that's why I'm laying emphasis on this. So, for this case, don't forget, s orbital has one degenerate, and so I'm seeing a 1 here. So, definitely I would have one. This is not paired, don't forget. So the question is, how many unpaired am I seeing here? The only unpaired I have here is this, because every other ones are completely paired. Yes, now if you try to draw something for this, you notice this one is completely paired. So the only electron or the only orbital that is not completely paired, that has an unpaired, is this 3s here. And so how many unpaired am I seeing here? I'm seeing only one unpaired. Only one is not paired there. So one unpaired electron. Now there is a way to answer it other than this one I have done. Now the idea is, I will do as to make reference to the idea of which orbital is not completely filled. The only orbital that is not filled here is the s orbital. This 3s here. The s orbital. Now definitely don't forget, I said the maximum number of electrons the s orbital can take is 2. The p can take is 6. The d is 10. The f is 14. And so what I needed to do is to remove the number of electrons here from the maximum number of electrons this orbital can take. Since this s orbital can take a maximum of 2, remove this one from these 2, and you have how many unpaired? 1 unpaired. 2 minus 1, you get a 1. That's 1 unpaired. Let's consider another. Ready. So I'm giving you a very quick trick to answering this one. Let's see. I have 1s2, 2s2, 2p3. Now, how many unpaired electrons are here? To getting the number of unpaired, don't forget, you should be on the lookout for which orbital is not completely filled. Look at this s orbital. Since I've already told you, the s orbital can take a maximum of 2. This one is completely filled. The s orbital, a maximum of 2, is completely filled. The p orbital can take a maximum of 6. So the only orbital that is not filled here is the p orbital. And don't forget, I said s is 2, p can take a maximum of 6, d can take a maximum of 10, f can take a maximum of 14. So then, from here, what will I do? Now, since I said this one is 3, so to getting the number of unpaired, remove this thing here, remove the number of electrons that you have in the p orbitals. From the maximum number of electrons the orbital itself can accommodate or take. Since the maximum number of electrons it can take is 6, and the number of electrons it has here is 3. 6 minus 3 is 3. Therefore, there are 3 unpaired. So there are 3 unpaired electrons. I hope you understand. So thank you very much. See you on the next one. Yeah. Now let's take another strange question. Another ways examiners can come is this. Now, how many unpaired electrons are there in nitrogen sublevel? How do you answer questions like this? How many unpaired electrons are there in nitrogen sublevel? Don't forget, nitrogen is the number 7th in the periodic table. The number 7th in the periodic table. So the first thing, questions like this requires you to understand the concept of electronic configuration. And so the idea is, let's go. Now, for the case of the electronic configuration of this element, now don't forget, according to Orbital's principle, go and check. I did a video on Orbital's, Pauli's, and Ohm's. Check those videos, you'll see them on YouTube. So kindly watch them, then make reference to that video, reference that video to this particular example, and you are good to go. Now, I'll write an electronic configuration for this particular area. Don't forget, I told you we come from 1s to 2s, 2s to 2p, 2p to 3s, and thereabouts. Now, the idea is I come from 1s, and I told you that the s orbital can take a maximum of 2 electrons, and I am going to 7. I've told you electronic configuration is a function of the number of electrons. So after 2s, I move down to 2. Sorry, after 1s, I move down to 2s. 2s2. How many more is needed to make it 7? So I needed 3 more, because I have 2 plus 2 is 4. 4 plus 3 is 7. Now the